Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called interval list intersections. So we have been given two lists of closed intervals and each list of interval is pairwise disjoint set, right? And they are in the sorted order. What we need to do, we need to find the intersection of these two interval lists. So let's do this. Let's try to understand this problem from this diagram that has been given in this example. So I copied this diagram here and I noted like intervals as well, 0, 2 and 5, 10 and etc, right? And let's try to understand. So what here the intersection really mean, right? So if I find the intersection between these two intervals, then what is my intersection? My intersection will be this part, right? Okay, and this will be intersection like this part. Between these two intervals, this will be like this. Okay, something like this. And then basically this will be 25 25, they are also intersecting. 24 24, they are also intersecting each other. And 5 comma 5, they are also intersecting each other. Okay, so these are all the intersections. Now if I choose the different color like yellow color, so these are the intersection we found so far. Okay, how we are finding these intersections, that's the interesting thing that we need to figure it out, and that's how we will build our algorithm. So this is like the problem, like these are the intersections and there's 24 24 and 5 5 25 25, they are also equal, they are coming to the border. So we are considering that border as well, border intersection as well. All right, so now let's see how we are choosing basically these intersections and how we will be building this output, right? This output. Okay, so between 0 and 1 we are picking 1, right? Why we are picking 1? Because 1 is coming after 0, so 0 will not be contributing to the intersection because that is basically here, so that will not be intersecting. That's why we are picking 1 here, right? And in this start, because they are equal, so it does not matter, they both are same. But in basically if we choose here between 5 and 8, what we are picking as a start? 8 we are picking, right? Because 8 is coming after 5. Similarly here between 13 and 15, what we are picking? We are picking 15 because 15 is coming after 13, right? Similarly here this is endpoint, but 24 24 they are same, so I think they will be same. 25 25 they are same, so it does not make sense to choose like what is bigger number or a smaller number or what is coming before or after, so it's fine, right? So long story short, here whatever the maximum out of these two, that is our start point. Similarly for the end point, what we are doing, we are picking out of 2 and 5, we are picking 2 because 2 is coming before 5, so that will be contributing to the intersection, right? Similarly between 10 and 12, what we are picking? We are picking 10 because 10 will be before 12 and that will be contributing to the intersection part. Similarly for 5 and 5, they are equal, so it basically it's fine to choose any of them because they are equal. Similarly out of 23 and 24, what we are picking? We are picking 23 because 23 is coming before 24 and that will be making the intersection, right? And they both are same, 24 24 and 25 25, they are same, so it does not make sense. I mean anything is fine to choose 24 24, right? So there is no bigger or smaller, so we don't have to decide. They any one of is fine because they both are 24, right? If the value is same, basically we need to pick up, we can pick up anything. If it is value is greater than or smaller, then we need to choose, okay, what we need to find, right? So in this case like 0 and 1, what is the decision number, right? What is the decision that we need to make, which number we need to choose? So here we need to apply some logic or something that, okay, 1 is coming after 0, so 1 will be the our start point of the output because that will be contributing for the intersection of the output. All right, so far what we learned here, let's quickly note down our notes. So basically the start would be max of given start points, right? And what will be the end? End will be basically the minimum of given endpoints, right? When I say given means given means like A and B, right? So given start point, what is given start point means here? the given start points is this 0 and 1, given endpoint is 2 and 5, so they are the given, right? Okay, so I think I wrote down here, somehow it came here, but we can write again, max of given start points. Similarly end would be minimum of given end points. So I need to click the done, otherwise it will again drag to the previous page. So okay, so we have found this observation, that's first observation. Now because there are two arrays here, I and j, right? I and j, I'm taking one pointers, basically the name as the I and j, but the array name is a and b. Okay, so the given arrays are a and b, and the pointers, let's say it is I and j. So now the next thing is how we are moving these pointers, right? Because that is also important. If we don't know how we are going to move these pointers, then basically also there is a problem, right? So let's consider first of all first interval and second interval. So we choose this intersection. Okay, which we found 1 and 2 of our pair of our output. Now should I move I or should I move j? Right, definitely I should move I because 2 is coming before 5, so I will be moving I, right? Okay, so I moved I here. Now my j pointer is here and I pointer is here. Now what should I move? Should I move I pointer and j point or j pointer, right? So now I found 5 and 5 pair as well, but now I have to move the j pointer, so j pointer will be coming to this interval. Why? Because this 5 is coming before 10. Okay, now what should I move? Out of these two intervals we found this interval, so very good, we will just do 5 5 and 8 10. And now basically we will check, okay, 10 is coming before 12, so it makes sense to move the I pointer now. So now we are on this interval for the I pointer, right? And now we found this interval as not this interval, but we are still on the j pointer here, right? So j we will be checking, okay, 12 is less than this 23, right? So now we will move the j pointer, and then we will find this interval, and then we will note down 15 and 23. Now we will check, okay, out of 23 and 24, which is coming before 24, or whichever is minimum, so 23. So now we will move I pointer, right? And then we will find this intersection 24 and 24 as well, right? So this is 24 and 24. And now we will check, okay, what is coming before, right? So 24 is coming before 25, and then we will move this pointer, and then we will find this interval as well, and that is 25 25, right? So what we learned so far, we learned whenever basically if it is ending, if one interval is ending in comparison of other interval, right? If it is ending before the other interval, then basically that is the pointer that we need to move, right? So if 2 is minimum out of 2 and 5, then we are moving I pointer. If for example 5 is lesser than 10, means 5 is coming before 10, then we are moving j pointer. So that's the basically observation. So let's go ahead and move let's go ahead and write down this observation as well, moving pointers. How we are going to moving pointers? Basically based on minimum end of given ends, right? So that is the moving pointers. So if we know basically these two things, how we are going to find a start and end, and how we are going to move the pointers basically between these two arrays, then I think we are done, and then we can just safely write our algorithm. So writing the algorithm is super simple. So let's go ahead and do that. I am just doing control Z here to undo the couple of things so that it will not be messed up. So now let's go ahead and move to coding part. So now let's first of all take the result array here. So list int res equals to new linked list integer m a dot length and a I think we don't need this thing, right? So let's straightforward, let's take 2 pointers here, I equals to 0 and j equals to 0. Okay, and these 2 pointers we need to move. So what we will do, if I is less than a dot length, because anyways we are checking only, we are using a dot length only once, so it's fine, we don't need to take any additional variable. And if j is less than b dot length, then what we are going to do, we are going to find our start and end, right? So that's what we see, we have seen here, right? So the first is find the start and end, and then move the pointers accordingly. So that's what we are going to do. So now find the start. So what is our start? Start is math dot max, right? That's what we have observed here, right? So start is the maximum of given start points and end is the minimum of given end points. So let's go ahead and do that. So maximum of a I, and then start is 0 because they are the pairs, right? So here if they are the pairs means they are given in the set of the 0 and 1, right? So 0 and 1, right? 0 and 1, 0 and 1. So 0th location will be the start point, and one's first location or first index will be the end point, not the location but the index, right? So first 0th index is the start um, of the first interval, right? So b, and then this will be the z and 0. So this is start, and what is end? So end will be math dot minimum of a I1 comma b j1. All right, now let's go ahead and end these, add to our result list. So that is start comma end. Now this is the time to move the pointer. So how we are going to move the pointer? Based on the end. That's what we have seen here, right? How we are going to move the pointers? Based on the minimum of end of given ends, right? So what are the given ends? If I1 is less than b j1, then what we are going to do, I plus plus else j plus plus, and that's it. Let's go ahead and return res dot to array. We need to typecast that because it is expecting this format, right? So new int, like that. Okay, now I still did not consider one edge case, but I just wanted to show that what is that edge case here, right? So the answer is wrong, and here we see 13 comma 12, and that is the edge case. So edge case means basically the start can also be greater than end, right? So let's go back to the our diagram. So okay, so this is the diagram. So here let's consider that basically my j is here and my I is here, and what is my start? So start is 13, and what is my end, right? So start, because I'm choosing like the maximum, so maximum is 13, and what is my end? So end is 12 in this case, but I don't want to add those, right? Because I want to add only start and end whenever start is less than end, right? So I just need to simply make this condition here. So if start is less than end, right? So that will solve this problem, 13 comma 12. This problem will be solved. Now what about 5 case and 24 24 and 25 25? They are also equal, and I need to consider those as well. So that's why I need to do here less than equals to, so that those cases will also be covered. So I think I am good now. Complexity wise, time complexity would be m plus n, and space complexity would also be m plus n. Why m plus n? Because let's say if they are completely disjoint, right? So here i'm I'm moving my pointers like this array, and then this pointer will also is also moving for basically for this length, right? So basically let's consider like they they are totally disjoint arrays. So in the worst case I need to traverse this complete array, and then I need to traverse through this complete array as well, and in the worst case I need to go through basically the till the length of both the arrays. So that's why it is coming as a m plus n, right? So time complexity, and the space complexity is also same, because space complexity we are maintaining this list as well. Now let's go ahead and try to compile, and let's see. Okay, so compile is fine. Now let's go ahead and try to submit. So I think this is working fine. Quickly, before ending this video, just quick summary, very quick summary. First of all, we will try to understand this problem from this diagram, and this diagram basically we will try to see that what is the intersection part, right? And we will try to find like what will be our start and end point of our output, right? And here we will observe the pattern. Okay, start point is basically we are taking 1 out of 0 and 1, because 1 is coming after 0, and that makes sense because 1 is contributing to make the intersection, right? That's why we are choosing 1. So whatever the maximum, right, whatever the maximum of given start point, that is our start. And similarly we will also choose the minimum, right? So what is the minimum we are choosing? We are choosing here basically out of 2 and 5 we are choosing 2, because 2 is coming before 5, so it makes sense to choose 2, because that will be making the intersection. So that's why we mentioned here that end is basically minimum of given endpoints. Now so now we already know that what is start and end point, but how we are going to move these pointers, right? Because we need to take the 2 pointers, right? Because they are the 2 arrays, we will just go one by one with the help of these pointers I and j, and these, with the help of these pointers, we will pick our start and end point, and we will keep populating our result array. So now this is another pattern that we found. Okay, if this interval is coming before this interval, what does that mean? That this interval is ending before this interval, then we need to move this interval pointer, right? So we need to move the pointer for this array. So we will be moving I pointer, and if this b ending, if it is ending before this, basically before I, then we will be moving this pointer. And that's how we will keep moving the pointer, and we will keep finding a start and end, and we will keep adding the result to our result array. Now the edge case we found like similar this kind of edge case, right? So let's say j pointer is here and I pointer is here, and then we found okay, start and end. So start in this case will be 13, and end basically in this case will be 12, because of our logic. So logic says that start will be the maximum of 2, so 8 and 13, start is 13, and then end is basically minimum out of 23, and 12 is minimum. So we are adding 12, 13 and 12, and that is wrong, right? Because start cannot be greater than end, and that's why what we are doing in our code, we are putting this logic to handle this special case, right? So we can say this is a special case where start cannot be greater than end, right? So this is how we are handling this case. Apart from this special case, like that's straightforward. I think this is useful. Thanks a lot. Have a good one. Bye.